welcome, everybody. I see a few familiar faces from the last few weeks. Thank you all for coming out to these. Oh, got it. All right. So I'm going to give a little bit of a switch up on these. I know some of you are very bored with some of the slides that I've given for the past 3 times now. So yay, with the Chesapeake Biological Laboratory. Founded in 1925 by Dr. Reginald Truitt. You're going to hear all about that tonight. And again, it's our 100-year celebration. And there's going to be events throughout the year that UMCs are doing. There's the QR code here. Please check out our website to look at the events. So we are the oldest state-supported marine laboratory on the East Coast. And we are one of 6 constituent members of the University of Maryland Center for Environmental Science. So we're a very unique institution. You know, universities are generally sort of one campus. We are 6 campuses spread about the whole state of Maryland, which is actually very advantageous for us. We get to work in the mountains. We get to work in the coast. We get to work downtown Baltimore. So there's 6 units all spread out, distributed across Maryland. And it's our mission to improve and preserve Maryland's natural resources and addressing very critical environmental issues, for which we have very many nowadays. We do this through innovative and cutting-edge research to advance scientific knowledge, but the key part is that we engage with the stakeholders and the managers of the state. That is part of our key mission statement. We are also Maryland's leading educator, training the next generation of environmental scientists. So thank you again for coming out to this series. This series is all to celebrate our 100 years here on Solomon's Island. And it kicked off, our first in the series was President Emeritus for UMCs, Dr. Don Bosch, who talked about his book, Predictive Ecology. For those of you who don't have it and want it, here's the QR code, 30% discount. So he kicked that off talking about the history, 100-year history of UMCs. I put this in because I kept talking about our buildings previously. And of course, the second in our series was Dr. Eshelman, who talked about the history of Solomon's. And you can see that even here on campus, our campus speaks to our history here on Solomon's. We have, our Solomon's House Visitor Center, that's 1780, that building. It was from Isaac Solomon, who the name is actually named after. Swift House, we have 2 of them, Swift House, Copp House. In the 1870s, they were basically from the oyster packing company. They were a company house. That's where the people stayed that were working with the oysters. We have Saunders House that you parked up from the 1890s. That's a general store, an ice cream parlor. We have Carey House down at the bottom of our campus, which was a marine hospital service building. We have Parish House, and of course, you're going to hear all about that shortly. And that was a former site of the Solomon's Episcopal Rectory, and first used the lab by Reginald Truitt. We have Nice Hall just across here. That was built in 1938 in honor of Edna Nice. You heard about that from Don Bosch in week 1. That was the wife of Governor Harry Nice. We have Becker House, and that was from the 1924. That was a general store, had living quarters above it, and then it was a laundromat. And so you can see we have lots of history here just on our campus that was spoken to in week 2. And then in last week, we talked about our 100-year history and water quality monitoring and the importance of these long-term monitoring data sets and what they're telling us now. You can see this is, the flooding by the Tiki Bar. This was last September. And you could see it wasn't just once. It happened every day, this flooding across where the Tiki Bar is. I got a car. I'm not going to cross that. So I timed when I came into work, thanks to this Patuxent Centennial website. So if anybody wants to know anything about the water quality, if you're a boater, you want to know if you can even come on the island, check out our Patuxent Centennial website. The QR code is there, or you can just Google that. But we've also learned a lot about temperature. The Solomon's climate stripes you just went past. This is our data back from 1938 to 2017, and it's our actual water temperature. You can clearly see blue, colder, red, warmer. That's the actual data. It speaks for itself. So as I said today, we're going to be talking, the next talk is Professor Tom Miller is going to be talking about, he's going to highlight Reginald Truitt, who is our founder, a true visionary and advocate for environmental health. Next week, Dave Secor will be talking about Dr. Mansuetti and his legacy here. And I mentioned this before, we love to name buildings against, those scientists who were instrumental to the Chesapeake Biological Lab, and also other people in the state that were also instrumental. So we have the Truitt Laboratory, Mansuetti Laboratory, Cronin Research Complex. He was our second director. Corey Hall was after Dr. Ernest Corey. Bevan Hall, and my favorite, this building, Senator Bernie Fowler's laboratory. So we've achieved many, many things in our 100 years, providing new insights on environmental issues. We've been very instrumental in defining all sorts of policies and management, reflecting our mission to the state of Maryland, on preserving our natural resources. We've also provided solutions to improve ecosystem restoration, biodiversity, fisheries management, and minimizing the impacts of human activity. So our environmental challenges continue, and they'll continue to continue. They're becoming increasingly complex and require all of us to help address and be aware of these issues. I'm bringing this up. This is our new building. You just walk past it here. This is a state-of-the-art meeting facilities, and that coupled with our UMC's Global Collaboratory Initiative, it seeks to address these complicated, these challenging environmental issues by bringing everybody together. We're going to put all voices to the table, the scientists, the educators, the policymakers, the NGOs, and the public and the communities. So our goal is to actually develop novel and innovative tools and different approaches to try to provide rapid and actionable solutions. And, I just want to emphasize that it's our shared responsibility to preserve our environment for our future generations. And I wanted to do a plug because it's that time of year. You're soon going to see dolphins. I was in Ocean City last week and saw a nice pod of dolphins going past. I couldn't get my phone out quick enough. So for those of you that don't have the Dolphin app, please download the Dolphin app. The QR code is there. So if you're ever out on the water or you're walking along, you can see them right here, walking along the pier on Solomon's. Take a picture, send it to us. This is a wonderful example of what I'm very proud CBL does, is our interaction with our community. And this is how you, as our community members, can help us with the science. So if you see a dolphin, log it, send it to us, and we have scientists here that verify that it's a dolphin, and it goes into a database. We might have one scientist working. You can't be everywhere in the Bay. So we look to you all to be the eyes and to help us with these projects. And so this is a highly successful program. It's been running for 8 years. I love this. I mean, that dog just wants to get in and play with it. I would want to get in and play with the dolphin. And there's some amazing pictures that you see. There's ones that are carving. There's ones that are playing. They're flipping a fish around. I mean, they're having a great old time out on the Bay. And the really cool thing is that we're learning where they are. We're seeing them further north in the Bay. We're seeing them potentially coming in sooner into the Bay. We're learning a lot about them thanks to the photos and the input that you provide. So just a plug for Dolphin Watch. Love that program. And then, so finally, I just had pointed out, I am clearly a scientist and I'm not an English major. My goal to celebrate our 100-year anniversary is just to get 100 donations. It can be 100 donations of $1. There's no limit, but I just want 100 donations to celebrate our 100 years. And that money goes to support our research, our education, our public engagement activities. But I just had it pointed out to me, wow, that's really ambitious. 100 donations for 100 years? I'm like, oh, no, that's not what I meant, but hey, I'll take it. So if you want to do 100 donations for the next 100 years, feel free. But I really just wanted to say, thank you for your support of our programs. Many of these things like Dolphin Watch, for example, are only possible through the generous support of our community. So in closing, This series is a celebration of our community, our scientists, students, staff, and you all. And again, thank you all for contributing and coming out tonight and showing your support. So thank you for that. And I would like to now introduce Professor Thomas Miller, who was, many of you know, our previous director here at CBL for 12 years. And his area of expertise is in fisheries ecology and management. And he's a global leader in the development of approaches to manage many of the iconic species here, the blue crabs, the oysters, many fish species. He's also an advisor to the state and the nation, serving on many fisheries councils and committees, and has done extensive work with the National Academies of Science, Medicine, and Engineering. And I could go through a 50-page CV, but I won't. And he's very engaged in our graduate education and has received lots of awards for excellence in teaching and mentorship. And if you want to know anything more about Dolphin Watch, Tom heads that program. So with that, I would like to introduce Dr. Miller for the next presentation.
Thank you, Karis. Thank you for the generous introduction. I'll make the donation afterwards. Seeing that list of buildings with names on it, my wife assures me I'll get a Rubbermaid shed, which I think is kind of appropriate. These talks are happening this semester really because of Karis's leadership, and I just want to take a moment to thank Karis for her leadership. This series of talks has been put on through a sheer force of will to get us to step up and continue this program, and it speaks a lot for the passion she brings to her work. So Karis, thank you very much for that. I was in Woods Hole last week visiting my cousin, John and Fran, and we've both reached an age where when we go to the doctor says, well, Mr. Miller, at your age, you have to expect. So we got talking about, the future, and my cousin said, Tom, if I ever am given a terminal diagnosis, one of the last things I would want to hear is you give a talk. And I said, John, that's amazing. Is it because of the strength of my arguments or how eloquently I speak? He said, no, whenever I speak, I hear you speak, it seems to go on forever and ever. So I hope this won't go on forever and ever. I am wanting to tell you a story about our founder. You heard in the first lecture, those who were here, some of the personal details behind the journey that Truitt went on in interactions with various people in the state to create this institution. I want to take a slightly different tack tonight. I want to talk about Truitt's legacy as a scientist and Truitt's legacy in this institution. And so I hope to give you some information that you don't know of. I hope you gain an appreciation of why we think so highly of this man. And I hope you get an appreciation of why we are so proud to be celebrating our 100th anniversary. But I'm going to start with another ex-CBLer. This is a book that Ralph Eshelman loaned me, wherever Ralph is in the audience. Sitting up front. This is the sort of philosophy of Tom Wisner, who was an environmental educator here. We say environmental educator, but he did far more than that. He brought a spiritualness to his environmental education. He brought a humanity to his environmental education, and he really was doing groundbreaking work. He left us and for a while taught a course through the university, and the course received rave reviews. It was a course on environmentalism in the Chesapeake, and he set homework like this. Find a hero or a heroine. Let your heart and your mind have equal choice. Choose one person and learn all you can about them. And so this creed has influenced this talk a great deal about who to choose and why to choose. And we're spoiled for choice, right? We can think of a lot of environmentalists who are worthy of respect. On the left, Rachel Carson. On the right, David Attenborough. Both in their own way changed our understanding of the planet and our role in preserving and conserving the planet. But I choose the remarkably named Reginald Van Trump Truitt, one of 5. This is Reginald here on the extreme right, as you're looking at it, of the screen. Notice there's a little bit of a swagger in the way he stands. That's a point we'll come back to as we go through it. You heard a lot from Don Bosch about this gentleman. Champion dancer, champion lacrosse player, trained to be a fighter pilot in World War I, landed the first plane on the Eastern Shore as part of a Liberty Bond drive. These are pictures from him landing on the Eastern Shore. As part of this drive, he took a young lady up for her first flight. Must have been absolutely terrifying, I would imagine, because flying was still a rare thing. He returned to College Park, helped 2 brothers called Wright land their plane at College Park for the first time. It's pretty remarkable that you're sort of one step removed from the Wright brothers. And really, in his post-professional career, continued to do remarkable things. And so Truitt is my choice for the hero, and I'm going to try and explain why I think he's deserving of that. Several of you have commented on my attire this evening. I thought if I stand there appropriately. Thank you. So the question we have tonight is why, when he retired, did this group of people who chaired the Commission on Research and Education for the State write this note of thanks to Truitt? Pioneer leader and authority in aquatic biological research, untiring and enthusiastic supporter of education, creative architect of Maryland's program of conservation, far-sighted founder of CBL, inspiring director, devoted member, fearless champion. I mean, you don't get that sort of thing when you retire normally. This man stood out. And the goal tonight is to try and explain why these people thought he stood out and why I think he stands out. Inevitably, I found when you tell historical stories, you begin to weave threads together that you didn't know were connected. So this is, again, Rachel Carson. She was a student at Johns Hopkins University, got her master's degree in 1931 for research on the nephrology and the evolution of nephrology in fish. She was struggling to find a thesis when a gentleman called Reinhold Coles suggested she work on fish. Why did Coles suggest she worked on fish? Coles was one of the founding staff members and advisors at CBL, and it was his experience working at CBL that convinced him that experimental studies on fish were the way to go. So even though Rachel Carson never worked here, was never part of this organization, as I said, there are threads in the tapestry of history that we sometimes find unexpected. So I'm going to talk about 4 things tonight. I'm going to talk about Truitt as a scientist, Truitt as a visionary, Truitt as an educator, and I think most difficult for me is Truitt's character. It is part of this message from Tom Wisner that we should understand our heroes for their achievements, for their failings, for their strength of character and their weaknesses. And so the last slide or two is a personal reflection of what I see as those aspects of Truitt's character. So we're going to start with Truitt the scientist. And the first question is, why should a man who was so successful athletically, right? He won the national championship for college, for University of Maryland in lacrosse and ran the track. Why should Truitt take a journey to be a research scientist for which at that time there was really no career? There wasn't the career path that there is today. Go to graduate school, become an academic, spend your life in an ivory tower doing research. It was a very risky move. And when he was in his sort of late 70s, he was interviewed by the Maryland Historical Trust as part of their oral history program. And they asked him that question, why? And his answers were really twofold. One was that he was a country boy, which, as we'll see, not so much as a grown-up. The second one was that he was absolutely intrigued by the Chesapeake Bay and the aquatic ecosystems. His father had had leases to grow oysters on the sounds inside the lagoons in the coastal bays. And he spent a lot of time on the lower eastern shore talking to watermen, trying to understand what they knew about the bay and what happened in the bay. And this was one of the quotes he got from an elderly gentleman when Truitt was a young man, so probably 1900, 1905, somewhere around there, talking to an elderly boat captain who would have been around when the Maryland harvest of oysters was something like 15 million bushels a year. And as you see, it forms just like snot in the nose, right? That was our understanding of what, or his understanding of what oysters were. And that really intrigued Truitt, that there was nothing known about this place that he felt so passionate about. So this is the foundation for Truitt as a scientist. Graduated from the University of Maryland, as it became. It wasn't University of Maryland at that point. Became a high school principal, did national service, as we saw in the Army Air Corps, learning to fly. After the end of World War I, he registered as a graduate student, again at College Park, and was appointed an instructor. Shortly after that, he was appointed a fisheries expert aboard the research vessel Albatross. This was run by the Bureau of Commercial Fisheries, which subsequently became NOAA, or the National Marine Fisheries Service. It was based in Baltimore, and it did survey work in the bay and up and down the East Coast. And he was working under the direction of a very famous marine biologist called Churchill, who did some of the foundational work on the ecology of crabs, amongst other things. Shortly after that, he was appointed to the Conservation Commission to do work on the idea of planting oyster seeds along Calvert Cliffs. So this was an idea that you would take seed oysters from productive grounds and move them to less productive, but formerly productive grounds along Calvert Cliffs. He was assigned a boat and a boat captain for his use, and he was headquartered on a shack on the beach in Solomons near the ice plant. Now, when I first started to explore Truitt as a person, I had heard this legend that he toured the bay and was looking for places to establish a laboratory. And some of that might have been true, but you can see there were lots of forces that were driving him to the Solomons area to base his establishment. So he was on the beach there for a couple of years, and then the Episcopal Church gave him use of their parish house. And at that point, he started to call his efforts the Chesapeake Biological Lab, and he was promoted to professor. Why was he promoted to professor? He'd had a job offer to head a fisheries unit of a New England state. He is circumspect about which state that was he'd spent a lot of time in Connecticut. Whether it was the Fisheries Department of the state of Connecticut remains unknown to all of us. But that issue of being headhunted by another organization led the Department of Zoology at Maryland to promote him to professor. In 1929, he was awarded his PhD from American University. Why from American University? Because at that point, College Park couldn't give PhDs in zoology. And so he got his degree from a sister institution. And by 1933, Chesapeake Biological Lab occupied the main building that we have for our administration now, Bevan Hall. That building was in plans from 1928. It was finally dedicated in 1932. Don Bosch talked about some of the politics behind that. As a former administrator, someone who's dealt with the state procurement process, I have to take my hat off to anyone who can get a building through the state procurement process in 2 years. The building that Karis talked about, when I first joined this laboratory in 1994, the then director said, and next year we're getting a new building. That's that building some 30 odd years later. So Truitt obviously knew how to pull the strings. So this is his doctoral dissertation from American University. The cover page, Biological Contributions to the Development of the Oyster Industry in Maryland. Why this interest? Truitt had watched oyster landings decline precipitously. They went from 15 million bushels a year in the 1870s and 1880s to 3 million bushels by 1918 to 2 million bushels by the early 1920s. That decline drove several responses. It drove lawlessness among the watermen themselves because they were chasing an ever-dwindling supply. There were gunfights over oyster harvests. There was illegal harvests. There was at the time private leases that were being raided. That led the state to set up a commission, this conservation commission, to try and bring order and understand what was going on. And Truitt desperately wanted to contribute to the understanding of why oysters had declined, and importantly, what could be done to rehabilitate them. So what's striking to me about this dissertation is the breadth of the material he traverses. So he gives a general introduction to the biology of oysters, largely based on the treatise of Brooks, a well-known professor at Johns Hopkins who published a heavy tome on the biology of the oyster. But Truitt then goes on a study of the salinity and temperature and, in fact, oxygen levels of Chesapeake Bay in general, a fairly broad study. He characterizes the bottom of the bay, where oysters were growing, what was the substrate like, what were the characteristics that promoted high yields, what were the characteristics that tended to diminish yields. He looked at reproduction in oysters and the factors that controlled reproduction. He looked again at temperature and light, pH. He looked at the incidence of storms. And then he began to look at public shell planting operations. So this is the first inkling to me that if you want to understand Truitt and his vision, you have to understand the breadth of his thinking. This is not just about oysters in one place at one time. This is a quest to understand the environmental forces and the sociological forces that are driving and drove the decline of oysters and perhaps are limiting their recovery. And it's this breadth of vision that I think marks Truitt as someone worthy of our respect. So, what was his vision? What went on from 1925, when he founded CBL, 1929 when he got his doctorate, 1932 when they opened Bevan Hall. What was the vision that was driving this? What enabled him to go from a shack on the beach to a borrowed house to this magnificent building in under a decade? What enabled him to buy high quality microscopes, something that he always complained about? He never had enough money for microscopes. What was it that drove that? At a time, remember, between 1923 and 1932, when the world and the nation were going through economic turmoil. What was that vision that enabled people to bet on Truitt when there were so many other worthy things to invest in? So this is Truitt's vision in his words, two quotes that I pull out as being indicative of them. I've struggled to find a clear statement where he says, this is what I thought was going on, but I think this captures the idea of what he thought needed to occur. So the first one talks about the waters of the state being dead, that the public viewed that the decline of oysters was because the water was bad. And the water was bad because of some external factor, whether it's oil in the water, whether it's some change in the physical nature. But it wasn't me, sir, it was the environment. So Truitt's response to that was, well, then we need to go out and survey the environment, the physical conditions of the water, the chemical conditions of the water, and the biological interactions that are occurring in the water to understand what those were and what those are. And he concludes that the waters of Maryland today, and this is speaking in 1932, are as potentially productive of oysters as they were in the days of the greatest abundance. So he concludes that there was nothing about the environment per se that was limiting oysters. So he set his goal to rehabilitate the oyster. He felt that it was entirely possible and reasonable to return Maryland's oyster abundance to its former heights and to increase the harvest of oysters if the fishery was only managed scientifically and appropriately. And Truitt was going to provide the science and indeed the management. Truitt wanted to understand the biology. He wanted to understand the physics, the chemistry, and he also wanted to understand why watermen were going where they went to fish, how they fished, when they fished. And as you see, he expanded his interests accordingly. So we'll see as we go through this that CBL eventually not only studied the aquatic conditions in the bay itself, but it studied upland streams. The Maryland Biological Stream Survey, which has been going on for years, has its birth at this institution with Truitt. He begins to study forest soils and runoff. He begins to study the games and parkland. There was no limit to what he thought fell under the umbrella of trying to understand the health of the bay. He starts out trying to understand the Chesapeake by doing what we would call fisheries ecology. Dave Seacon, my colleague in the audience, and I would recognize everything that Truitt does as fisheries ecology. But he says that's not enough. That's where most people had stopped up to that point. He said, I can't do just that. I also need to do what scientists today would recognize as physical oceanography. Study the movement and chemistry of the water and how those conditions changed. And then he said, but I also need everything else. I need the biological components, and I need what he termed frequently the ecology and conservation, which was this watershed level interface. And if you look at the publications this institution created between its founding in 1925 and his retirement in 1954, it tells part of the story. So in the first decade of his time, he produces 6 papers, all of them on oyster fisheries, all of them talking about the economics and the management of the oyster fishery, about how having a fishery in September is a bad thing because it competes with agriculture. And we need to change the dates of the season to increase the economic yield. In 1932, he gets the new building and he begins to get a little bit of money. And the breadth of studies begins to change. So over the next decade, you begin to see papers coming out on what we would call physical oceanography. You begin to see papers coming out on biological oceanography, a lot more papers on fisheries ecology, but now he's moving on from oysters to do crabs and croaker and silver sides and marlin. I mean, just an amazing range of things. And when I say he's doing that, he's doing some of that, but a lab director in those days had power. Unlike in my day or Karis's day, when we have absolutely no control over our faculty at all, Truitt had complete control over the people he worked for. He directed what they would work on. He said, you're coming and you're going to work on the blue crab problem. You're going to work on the rockfish problem. You're going to work on hydrology, as he called it. And so really, this is Truitt's vision of what they should work on. The findings were the individual scientist's own creativity, but the driving intellect behind all of this is definitely Truitt's. And if you move forward from 1945 for the last decade of his directorship, you see a fairly even spread across all 4 of those topics. So if you've got 3 hours, I can tell you an awful lot about an awful lot of incredibly innovative, creative, and groundbreaking research that Truitt and his team did. They did work defining the temperature, salinity, and oxygen distribution in estuarine waters. They characterized nitrate phosphate distributions in estuarine waters. They calculated alkalinity. They measured flows, defined stratification. All things we are still studying today. The foundation of that work comes from this institution at Truitt's direction and at the start from the staff he appointed. They did an awful lot of work on an animal called Cleona, which is a boring sponge. I think many people think sponges are pretty boring anyway, but it's not boring in that sense. It's boring as in boring a hole in something, and they bore holes in the shells of animals, particularly oysters, and they cause tremendous damage to oyster shells that force the oyster to invest metabolic energy into shell deposition rather than growth, or they outright kill the animal itself. So an awful lot of work was done on Cleona. They did an awful lot of work on jellyfish, on primary production, and interestingly on pollution in Baltimore Harbor. So you hear about studies of pollution in Baltimore Harbor, starts here with Truitt and this institution. A lot that I've mentioned on fish, a lot that I won't mention in any more detail on the ecology and conservation areas where they looked at plant community dynamics, first in Calvert County and St. Mary's, but subsequently statewide. He really got up into the watershed to try and understand what was going on in the watershed. And as I said, he established the Maryland Biological Stream Survey. Quite a remarkable achievement. I'm going to capture a few vignettes of some of these. I'll talk first about oysters because that was Truitt's first love. As I've said before, oyster harvest fell precipitously, Maryland, from 15 million bushels to the time CBL was founded of less than 2 million bushels. Truitt was a master at telling people why that mattered, right? And he told people why that mattered by comparing the loss of oysters to its equivalent weight in beef cattle, right? And he showed that the loss in oyster harvest from 1880 to 1920, back of the envelope calculations, was the equivalent loss of 1.6 million cattle, more cattle than live in Merrill, right? He was trying to communicate, and that's one of the messages that comes through with Truitt. He was a master communicator to the general public. Yes, he could communicate with scientists. Yes, he could speak in abbreviations that no one understood, but he could also talk to the person on the street and convince them that his work was important and worth funding. This was Truitt's early work that eventually led to his PhD, but he was out there measuring everything. He was measuring the amount of oysters on individual oyster bars. He was measuring mortality rates on oyster bars to try and establish which bars were most likely to be supportive of what he called aquaculture. They set up a demonstration farm over at Honga River on the other side of the bay, almost directly across from the mouth of the Patuxent. And as ever with Truitt, never was done in halves. This demonstration farm was 40,000 bushels of oysters, 50 tons of material to prepare the bottom, and its first year produced 50,000 bushels of year production, right? He was showing people how to do it at scale, not in a small lab experiment, but he went right out and did everything at scale. And he recognized early on the challenges of the program that the state was pushing, which was planting oysters off Calvert Cliffs, telling everyone when and where they were going to plant them that spring. So that summer, none of them were left, right? They were all harvested out before they would have reached market size. Don Bosch has a chapter in his book that says it's all about oysters except when it's about blue crab. And early on in his career, Truitt also recognized the decline in blue crab and wanted people to be aware of its importance. This is Truitt's writing. This is typical of Truitt's writing. Grabs you by the throat and shakes you, right? Why are crabs scarce and therefore dear? And what can and ought to be done to save the crab from permanent annihilation? Right? It wasn't, hey, people, there's a problem. You should be a little bit concerned. I mean, it was, this is important stuff and you need to pay attention. So, of course, as a crab specialist, I took a lot of interest in what Truitt did. The watermen believed that they could do with crabs what they were trying to do with oysters, or what the state was trying to do with oysters. That is, they could move crabs around and promote reproduction. And the idea was the crab fishery was concentrated around Crisfield. So let's bring sponge crabs, that is egg-bearing crabs, into the waters around Crisfield, leave them there, and there'll be lots of crabs 6 months later. So Truitt set two of his team, Graham and Bevan, to study the problem. So what did they do? They went and got barrels of sponge crabs, moved them up to Crisfield, let them go in controlled areas, and monitored them. They showed that some of the sponge crabs survived, although a large fraction of them died. Some zoea, that is young crabs, hatched, but none of them metamorphosed. The environmental conditions were wrong. Truitt moans that he had shown them that water conditions there inhibited the hatching of eggs, and it took 4 years to live down scientists are against watermen. He was a lucky man if it took 4 years. in my experience, that's a rocky relationship that can go south quickly. And you really have to work with watermen to understand their motivations and interests. They have a huge amount of knowledge that can be really helpful as we manage the natural resources. But it is quite easy to be put on the wrong side. I remember vividly, hadn't been here very long, and I was on a local TV news station with a waterman arguing about the natural mortality rate of blue crabs. And you calculate that by how long they live. And I said, crabs, based on the scientific evidence, crabs live to be 8. And this waterman whips out from behind his seat a magic 8 ball, shakes it, turns it upside down and says, not likely. But that was it. I had lost my argument entirely. And it took a while. It took a little more than 4 years to gain that trust back. Truitt motivated some of the most exquisite descriptions of the reproductive ecology of almost any animal I've ever seen. One student, Hard, did it for the ovarian cycle for the female crab. Just spectacular microscopy going from immature to mature crabs, showing that female crabs could store sperm and produce multiple broods. The first time that had been shown physiologically, or at least demonstrated physiologically. And then one of other students for the Truitt work with Gene Cronin, who, as we heard from Karis, and we'll hear later next week, became second director, did exactly the same with the male reproductive system. And the standard of work that is done at this time by these people on this topic and on others is just a joy to behold. For me as a scientist, to see the caliber of the illustration, the carefulness of the preparation, it is simply amazing. They did a lot of studies on blue crabs. This is a plot of initial width of blue crabs and the percentage they grew each time they molt. I did similar experiments when I first came here with 40 crabs in typical Truitt style. This is 450 crabs. If you're going to do something, do it big. They were interested in growth for 3 main reasons. In fish, there is a lot of evidence that you can tell where fish have come from by their shape. Although they're all herring from different regions look subtly different. And if you can measure them appropriately, you can say that herring came from the Grand Banks, that herring came from the Scotian Shelf, and that herring came from George's Bank. And they wanted to do the same thing with crabs. Could we tell where crabs came from? Because no one had any idea of the life history of crabs. And they found very early on that they couldn't do that with crabs. They wanted to know how many molts does a crab undertake to reach mature size. Graham Newcomb found that in 1939. How does a crab control its growth? That problem wasn't really solved until a PhD student here in 1997. So there are legs to Truitt's work that have influenced this institution for a long time. Truitt did tagging studies from 1924 to 1953. I can't find a single paper where they analyzed the tagging data. So I found the tagging data and started analyzing it. So these are data from 1937 showing the difference of movement between spring and autumn of tagged crabs released by Truitt, female in pink, male in blue. You'll see that the animals move a lot more in the autumn. The females move more than the males. And if you look at the directions that they moved, females are moving almost due south. Females are migrating down bay, males are hanging out wherever they are. That information Truitt knew. He knew the interpretation of these data. I just can't find anywhere it was ever written up. I talked about physical oceanography. Very early in Truitt's tenure, he developed a transect of stations up the Patuxent River. very similar to the Patuxent River cruises we're doing now. And he occupied those stations frequently, at least 3 times a year, often 5 times a year. Whenever they could, they went out to them and they measured the physical characteristics of the water. They showed that as early as 1930s, there was a problem with low oxygen, seen here in the middle part of the Chesapeake Bay during the summertime. That oxygen levels were down around 10 parts, well, saturation, about 10% of their fully saturated level. One of the Truitt's scientists, Curtis Newcomb, took that data going up the river and looked at the range of oxygen saturations going from station 1 here on the left, which is in the bay, all the way up to station 21, up here, well up into the tidal fresh section of the river. And if you look at the range, you can see that water becomes sort of healthy oxygen-wise, somewhere around 50 or 60% by about station 12 or 13. So somewhere up around Brooms Island, we were beginning to see good water quality, right? That paper, Don said, was the first science paper UMSI's produced. I'll show you the first science paper in a minute. But that's remarkable to me that a few years after the institution was created, it was publishing in the premier journal. Curtis Newcomb was replaced by a man called Olson. And the first thing Olson did was develop a new way of measuring water temperature. It had been done before by taking bottles down that close. You bring the sample up and you physically measure the temperature. It was sometimes done by sending min-max thermometers down, and you get very, very crude approximations. So if you look at this middle panel, these triangles are the traditional values of the oxygen concentration in mid-May at the Chesapeake Lightship, and at Cape Charles, similarly, you see a measurement about every 5 meters or so. With Olson's instrumentation, he could measure it every 10 centimeters. And he produces much more refined understandings of the temperature structure in the water, showing strong thermal stratification that's not apparent when you have this highly dispersed water sampling. They then stuck it off the end of the lab pier and said, not only can I sample in high frequency in depth, I can sample in high frequency in time and in ultra high frequency in depth. It's an example of how new breakthroughs in instrumentation allow you to ask new questions in science. And these high frequency observations that are exemplified in these 2 figures from Olson's paper are the kind of thing that ultimately led us to be able to describe current flow in the bay from first principles rather than measuring it. Biological oceanography, lots of work, I said, on sea nettles. Those studies were initiated in 1935. 2 years later, Littleford and Truitt, in what was the first science paper that the institution produced, closed the life cycle of sea nettles in laboratory conditions. Quite a remarkable achievement given the complexity of the sea nettle life history. And then a few years later, Littleford went on to produce a treatise on describing the individual life stages and the transitions between them. Again, another beautiful piece of work. We also had people working here on copepod taxonomy. I stand here in awe of having tried to identify copepods. I stand in awe of the ability to produce these diagrams and see these structures. Davis did some remarkable job identifying the primary species of copepods in the bay. But not only did they do that, the scientists at CBL were beginning to ask questions about how do we turn an information that this animal was present in this net and this many of them were present, how do we turn those into data we can analyze scientifically? And they were doing repeated measures of the degree of uncertainty that you got in counts depending upon the number of organisms in the sample. Quite advanced work that was going on in the 1930s. So just to wrap up the history, some odds and sods that were too good to omit. Karis mentioned the pier constructed in 1937. The first equipment house went out there in 1939. We've been measuring conditions since 1938. That's what drives our climate stripes. They loved rockfish. I think you're going to hear a lot more next week from my colleague Dave Secor about rockfish. The other thing they loved was tagging. In 1936, they tagged 11,000 fish. They preserved 5,000 stomachs. The next year, they tagged another 3,500 fish, and they initiated scale aging. Very early on, they had clearly established that the number of striped bass that join the stock varies a lot from year by year, an important observation. They identified compensatory growth shortly thereafter. They held rockfish in tanks in Bevan Hall. If you know Bevan Hall, see where my pointer has gone. This is the staircase up to the library. This is the corridor that you go down to the administrative offices. And this, if you go down to the basement, you'll see there's a big metal pipe from the floor up to the ceiling. Why? Because they had cement tanks holding striped bass in that corridor. They held them for 4 years until they matured and had them spawning, or at least running, in the tanks. The other thing I didn't know, in 1939, Truitt initiated juvenile seine surveys around the bay, something now that is a mainstay of fisheries management, conducted by multiple states up and down the coast. Truitt initiated it in 1939 here at CBL. This is one of his colleagues. This is Dr. Vladimir Vladikov, who was a Russian emigre, trained at the Sorbonne, went to Canada, came down here for 5 or 6 years, and then went back to Canada and had an illustrious career in ichthyology in Canada. But it speaks to the kind of people that Truitt was attracting to the institution. And I already mentioned that they did early foundational work on Baltimore Harbor. That's important enough, but they had to develop the methods to measure iron concentrations. So they did chemical speciation very early on to measure the concentration of the different types of total iron and soluble iron, as well as measuring pH, which controls its distribution. Just some amazingly good work. All right, chapter 3, Truitt's contributions as an educator. Not much to say about these last two, but I do want to spend some time on them. Truitt was passionate about the role of education, and he felt that conservation and fisheries should be part of any modern curriculum. And part of the tension that Don Bosch spoke about in the first week was Truitt constantly telling the people at College Park, you should be teaching this. And they said, well, we've got lots of pre-med students and pre-dental students and everything else. We don't have space for this. You should be teaching this. He developed detailed proposals for curricula. And when College Park didn't teach it, he said, okay, I'll teach it. And so they implemented summer schools. The lab held summer schools from 1933. So when Bevan Hall opened, for at least the next decade. They stopped in 1942 as a result of World War II. We sort of continue them today as part of National Science Foundation. project called Research Experience for Undergraduates. It's run by Marilyn C. Grant. They were sort of 4 to 6 week periods, and you got lecture and field, and you were taken out in the field. You were expected to make collections, to make observations, and you were expected to conduct research. Truitt strongly believed that research was an essential element in any educational programs. We have the original paperwork from 1936 and 1937. You can see you can stay in the best hotels. I'm not quite sure where those were, but evidently you could stay in them. But you see the curricula here that reflect what Truitt thought should be taught on the main campus and that wasn't being taught. And this biological problems was his catchphrase for research. And to look at these pictures, to me, is just remarkable. To see the range of young people, what strikes me is the fairly equal numbers of men and women in this. What always strikes me when I see a picture of Truitt out in the field, here he is bending over, looking probably at crabs in a float, is he wears white. He is always spotless. I don't know how he does it. It is a mystery to me. This is Bevan standing next to him in the natty Speedo. But you can see they were involved. They weren't just observing. All of them are out there doing research. This is our nice hall over here. This is where we have informal seminars. This was the dormitory space. This was the gentleman's dormitory space. Not much privacy I see going on there. Sadly, we have lost touch with these students. We don't know their names. We don't know what they went on to. It would be wonderful to understand what impact these experiences had on their lives. So the last one is Truitt's character. And I go back to Tom Wisner's class charge, which was to make a friend of your hero, know them as fully as you can, their faults, their failings, as well as their achievements and vulnerabilities. So the achievements, I think, are clear. I hope you've gathered them from my talk tonight, right? He implemented an ecosystem-based approach to fisheries a generation earlier than anyone else. Not a year or two, but a generation earlier than anyone else. He built this institution by pure force of will, and it has stayed true and expanded on his vision for 100 years. We are an institution that has provided actionable scientific advice to the state, to the region, for the nation, for generations of scientists. Those of us who are lucky enough to work here now stand on the shoulders of some giants. That heritage provides us with unparalleled access to decision makers. The type of access that Dave and I and Bill and Karis have to decision makers, and Jackie and Lee at the back, and Dong at the back, the kind of access we have to decision makers is unparalleled for a university. And that rests on this foundation. He created and nurtured an academic community. If you hear his daughter, Truitt Guthrie, give remarks that are available on our website, she talks about the strong sense of community that he created with international scientists from Denmark, from the UK, from Russia, as we've heard, from France, from Canada, from the US, and he created a wonderfully warm community. He trained and mentored some phenomenal students. And after his career, he didn't stop. Assateague National Seashore, thank you very much, Dr. Truitt, largely at his pushing. Character. I struggle with this one. I hold this man in the highest regard. And I've struggled with what his character was because I never met the man. I've talked to his family members. I know that they have been upset by some of the characterizations others have made of him. I know people who have suggested that Truitt was racist because of a friendship with Curly Bird. As you've heard from two presentations, at least here, there was no friendship between those two gentlemen. Truitt was a man of his time. Whether or not he held modern views, I don't think is a relevant question, but there is certainly no evidence I've ever come across in his writings to suggest an overtly racist character as there was in Bird's character. But I have to say something about the man. And I've come to the conclusions that every character trait I think of are opposite faces of the same coin. So he was clearly charismatic and charming, right? He was engaged at one point to the daughter of the ambassador to France, ended up marrying the governor's daughter. You don't have matches like that if you're not characteristic and charming. He funded most of his early work on the sort of after-dinner lecture theatre series. He gave talks to Rotary clubs and any group he could possibly talk to. At one meeting in Baltimore, he convinced the owner of Buck Glass to make him 300 sealed glass bottles that he could use as drifter floats to understand where the currents went, right? You don't get that kind of response if you're not charming and charismatic. But what's charming and charismatic to some can engender jealousies in others who saw that charm and that charisma being used to supplant their hard work and their more traditional approach to things. He was highly principled. It is clear in his writings, this man believed sincerely in doing the right thing, in treating others well. But he was also unforgiving. You read some of his letters later on in life, and there are some very marked comments about people because he believed they weren't as principled as they should have been. And that unforgiving nature probably earned him more than one enemy. He was also extraordinarily single-minded of purpose. You don't build an institution like this without being single-minded of purpose, without having vision. So achievement requires drive, and he had that in abundance. But he also had a with me or against me attitude that comes with that drive. You're either part of the solution or you're part of the problem. I'm going to work with people who I think are part of the solution. And that has created some really strong opinions about Truitt. I tend to lean on the positive side of all of those. Others have been less charitable. So what do we say about this man? He is a hero of mine. I hold him in highest regard. And I'll end by a quote from another man I hold in high regard that I think speaks to his legacy. If we lay a strong enough foundation, we'll pass it on to you, we'll give the world to you, and you'll blow us all away. I hope if Truitt could see what his institution has become in the 100 years since its founding, he would understand that we've lived up to that heritage, and I hope he would feel that we've blown him all away. So with that, I'll close and I'll happily address any questions.